Article 110.26 C2 of the National Electrical Code, or NEC, addresses the requirements for exits from electrical rooms. This section allows for a single exit from an electrical room under specific conditions, primarily when a continuous and unobstructed way of exit travel is provided. It's crucial to understand what constitutes a continuous and unobstructed path and how this provision applies in various scenarios. The NEC doesn't explicitly define the presence of a door on the electrical room as a violation of this rule, nor does it specify a maximum travel distance to the exit. However, the intent is to ensure that personnel can safely and quickly evacuate the room in case of an emergency. Therefore, the interpretation of unobstructed becomes critical. In practical terms, a continuous and unobstructed way of exit travel means a clear and accessible path from any point within the electrical room to the exit door, free from obstacles that could impede or delay evacuation. This includes ensuring that the pathway is not blocked by equipment, storage, or any other items that could obstruct movement. The absence of specific door-related language in the NEC doesn't mean doors are irrelevant. Doors are necessary for security, environmental control, and sometimes for fire protection. However, if a door is present, it must be readily accessible and easily opened from the inside without the use of a key or any special knowledge. This requirement is often met by using panic hardware, especially in larger electrical rooms or where multiple personnel may be present. Panic hardware allows for quick and easy egress by simply pushing on a bar or plate, which immediately releases the latch. Considering the scenario of an electrical room with a 3000 amp service measuring 16 feet in width located directly inside a double door, several factors come into play. Firstly, the presence of a double door itself doesn't inherently violate the unobstructed requirement, provided that both doors are easily operable and equipped with appropriate hardware, such as panic bars. Secondly, the size of the service and the potential for multiple personnel to be working in the room simultaneously should be considered. A single point of failure, such as a fire blocking the exit, could trap occupants inside the room if there is only one exit. This is a significant life safety concern. Given these considerations, it's essential to evaluate the specific characteristics of the electrical room and its usage. Factors such as occupancy load, room size and configuration, the presence of hazardous materials, and local building codes and fire regulations all play a role in determining whether a single exit is sufficient or if a second exit is required. Occupancy load refers to the number of people who are expected to be present in the electrical room at any given time. If the room is typically unoccupied or only occupied by one or two people for brief periods, a single exit might be acceptable, provided that the exit path is clear and the door is equipped with panic hardware. However, if the room is larger and frequently occupied by multiple personnel, a second exit is generally recommended to provide an alternative escape route. The size and configuration of the room also matter. A small, well-ventilated room with minimal equipment may not pose as much risk as a larger, poorly ventilated room with extensive electrical equipment. In a larger room, the potential for a fire or other emergency to block the single exit is higher, making a second exit more critical. The presence of hazardous materials, such as flammable liquids or gases, or the presence of electrical hazards such as exposed conductors or energized equipment, can also increase the risk of an emergency. In such cases, a second exit is often required to provide a safer means of evacuation. Local building codes and fire regulations may also have specific requirements for electrical room exits that go beyond the minimum requirements of the NEC. These codes may mandate a second exit based on the size of the room, its occupancy, or the type of equipment it contains. It's essential to consult with local building officials and fire marshals to ensure compliance with all applicable regulations. In summary, while Article 110.26 C2 of the NEC allows for a single exit from an electrical room if a continuous and unobstructed way of exit travel is provided, this provision should be applied judiciously, taking into account all relevant factors. In the case of a large, high-occupancy electrical room, or where there are concerns about life safety, a second exit may be required by local building codes or fire regulations. Panic hardware on the door may not be sufficient in these cases, as it only addresses the ease of opening the door, not the availability of an alternative escape route. To make an informed decision about whether a second exit is required, a thorough assessment of the electrical room should be conducted. This assessment should include an evaluation of the occupancy load, room size and configuration, the presence of hazardous materials, and applicable local building codes and fire regulations. The assessment should also consider the potential for a fire or other emergency to block the single exit and the availability of alternative escape routes. Based on this assessment, a qualified electrician and local building officials can determine the specific requirements for the electrical room in question. They can also provide guidance on the appropriate type of exit hardware, such as panic hardware, and the placement of exit signs and emergency lighting. In addition to the requirements for exits, the NEC also contains other provisions that are relevant to the safety of electrical rooms. These include requirements for working space around electrical equipment, adequate lighting, and ventilation. Working space is the clear area around the electrical equipment that is necessary for safe operation and maintenance. The NEC specifies minimum dimensions for working space based on the voltage of the equipment and the presence of exposed live parts. Adequate lighting is essential for performing electrical work safely. The NEC requires that electrical rooms be provided with sufficient lighting to allow personnel to see clearly and avoid hazards. Ventilation is necessary to prevent the buildup of heat and humidity, which can damage electrical equipment and create a hazardous environment. The NEC requires that electrical rooms be adequately ventilated to maintain a safe and comfortable working environment. By complying with all applicable requirements of the NEC and local building codes, it is possible to create a safe and efficient electrical room that protects personnel and equipment. The interpretation and application of Article 110.26 C2 requires a comprehensive understanding of the NEC local building codes and fire regulations, as well as a thorough assessment of the specific characteristics of the electrical room. Consulting with qualified professionals is essential to ensure compliance and to protect the safety of personnel. The concept of a continuous and unobstructed way of exit travel is central to the safe design and operation of electrical rooms. This principle extends beyond simply having a clear path to the exit door. It encompasses a holistic approach to safety that considers all potential hazards and ensures that personnel can quickly and easily evacuate the room in an emergency. Firstly, the exit path must be free from any permanent or temporary obstructions. This includes equipment, storage, furniture, and any other items that could impede movement. The path should be wide enough to accommodate the expected number of occupants, and it should be clearly marked with exit signs. Secondly, the exit path should be adequately lit. This is especially important in the event of a power outage, when emergency lighting should automatically activate to illuminate the path. The lighting should be sufficient to allow personnel to see clearly and avoid tripping hazards. Thirdly, the exit door must be readily accessible and easily opened from the inside without the use of a key or any special knowledge. This requirement is typically met by using panic hardware, which allows for quick and easy egress by simply pushing on a bar or plate. The door should also swing in the direction of egress, and it should not be blocked by any objects on the outside. Fourthly, the exit path should be free from any hazards that could impede evacuation. This includes slippery floors, uneven surfaces, and protruding objects. The path should be regularly inspected and maintained to ensure that it is safe and accessible. Fifthly, the exit path should lead to a safe and accessible area outside the building. This area should be free from hazards such as traffic, fire, or other emergencies. The area should also be adequately lit and marked with signage to direct personnel to safety. In addition to these physical requirements, it's also important to have a well-defined emergency action plan that outlines the procedures for evacuating the electrical room in the event of an emergency. The plan should include procedures for notifying personnel of the emergency, assisting disabled individuals, and accounting for all occupants after the evacuation. The plan should be regularly reviewed and updated, and personnel should be trained on its contents. Regular drills should be conducted to ensure that personnel are familiar with the evacuation procedures. The frequency of drill should be determined based on the occupancy load and the potential hazards in the electrical room. The importance of a second exit cannot be overstated, especially in larger electrical rooms or where there are potential hazards. A second exit provides an alternative escape route in the event that the primary exit is blocked by fire, smoke, or other obstructions. The second exit should be located as far as possible from the primary exit to provide maximum protection. The second exit should also meet all the requirements for a continuous and unobstructed way of exit travel. In some cases, a second exit may not be feasible due to the physical constraints of the building or the configuration of the electrical room. In these cases, other measures should be taken to enhance safety, such as installing fire suppression systems, providing additional ventilation, and implementing stricter safety procedures. The decision of whether to provide a second exit should be based on a thorough risk assessment that considers all potential hazards and the potential consequences of an emergency. The risk assessment should be conducted by a qualified professional such as a safety engineer or a fire protection engineer. The risk assessment should be documented and reviewed regularly. In conclusion, Article 110.26 C2 of the NEC provides flexibility in the design of electrical room exits, but it also places a strong emphasis on safety. The provision for a single exit is contingent on the presence of a continuous and unobstructed way of exit travel, which encompasses a holistic approach to safety that considers all potential hazards and ensures that personnel can quickly and easily evacuate the room in an emergency. When evaluating whether a single exit is sufficient, it's essential to consider the occupancy load, room size and configuration, the presence of hazardous materials, local building codes and fire regulations, and the potential for a fire or other emergency to block the exit. Consulting with qualified professionals, such as electricians, building officials, and fire marshals, is crucial to ensure compliance and to protect the safety of personnel. Remember that panic hardware addresses the operability of the door, not the availability of a redundant escape route. A comprehensive safety plan, including regular drills and training, is also essential to ensure that personnel are prepared to respond effectively in the event of an emergency.